Okay, well, welcome back. And we're going to continue our application looking at law of sines and law of cosines. So now we have one which is a glide path, and you really want to know how to set up these types of problems. So what we have right here is a pilot has just started on a glide path. I can't talk for landing at an airport where the length of the runway is 9,000 feet. All right, so what I always do is I always use draw a figure. Well, that's what I'm going to do. Draw a figure that usually represents the problem. So I usually just draw a picture either way. So I'm going to do part A. All right, right here. So this is going to be 9,000 feet. All right, that's a pretty big runway. And then you have this airplane. All right, I'm going to draw a little airplane here. I'm famous for drawing great pictures. All right, and there's a little. All right, so there you have the airplane. And the angle of depression from the plane to the ends of the runway, so here's one end, and here's another end, is 17.5 degrees and 18.8 degrees respectively. So what you have right here is you have this angle of descent, all right, coming down, all right, right there it's going to equal um, 18 point, all right. So if you keep on going out this way, it goes, the angle depression is going to be right here. So that angle of depression, we're going to say is, one of them is going to be 17. So this is probably going to be the smaller one. All right, 17.5 degrees. And then there's going to be another one right here. And obviously these are not drawn to scale. So once again, not to scale. Just remember that this is not to scale. But we have another angle of depression at the other end of the runway, which is going to be right here, which it says is 18.8 degrees. Okay, and so that is what we have here. So make sure whenever you're doing angles of depression, you draw out your horizontal, and they have to come down from there. So we have this 17.5 and 8.5, and we have 9,000 right there. So now what we're going to do is we're going to find the air distance the plane must travel until touching down on the near end of the runway. So find the air distance that will be traveled. And so in order to find this air distance that's going to be traveled, okay, what we're looking for is really, we're looking for what this length is, okay, that length is. So for the air distance traveled from, so touching down to the near end runway, okay, we're going to be looking for, we'll call this X, okay, we'll just call that X. All right, you can call it N2 if you want for near runway, but we're looking for that distance. Now, from here, we can see that we have a triangle. We have an angle that we can possibly find. But what do we know about this? Well, this is the cool thing, is that with geometry, if I extend this out, I have two parallel sides. We have the horizontal, and we have, if the plane would just keep going straight, and also we have the ground, which it is parallel to. So that means that according to alternate interior angles, this angle is actually the same as this angle right there, which is going to be 18.8 degrees. Okay, 18.8 degrees. Now, if that is 18.8 degrees, okay, that means that this right here, what angle is that going to be? Well, we know that from this point, okay, this angle right there is going to be, all right, 18.8 minus 180, and which is going to give us 160, 1.2 degrees, 116.2 degrees. Okay, and that's what we have there. Now, the other thing is, from this, is that now we can also find some other values as well. Okay, if we know that, if we want to figure out this angle, okay, and this is what we're going to do. I just like to find all these different angles. So if we want to find this angle right here, we know this is 161.2 degrees. Well, this whole angle is 18.8. We know that this angle right there is 17.5. So what does this angle right there have to equal? Well, we know that the whole is made up of these two angles. And if we want to figure out this angle right there, which is actually going to be the triangle that we're looking for X, right, like that, we know that that's going to equal 18.8 minus 17.5. And I'm running out of room right there, which then is going to equal, well, if you put that in your calculator, okay, or you probably figure out 18.8 minus 17.5, and you're going to have 1.3. So that's going to be 1.3 degrees. Okay, so 1.3 degrees. So we have this angle, and now we probably want to figure out what this angle right here is. Okay, and this is going to be called angle X. Okay, we'll call this angle X, big X, big X. All right, because it's opposite that one. So from here, we can take 161.2. Okay, or we also know is from this point right there is that we can also use alternate interior angles. So if we look at this one, and this is that transversal, we know that this angle and this angle also have to be equal. So we know this is 17.5 degrees. So we figured out all the different angles that we may need in the future, because I don't know what all the other problems are doing, but I just find all angles right off the bat. And so now with that, we can maybe rewrite this. I'm going to just redraw this because it's going to be look a little bit nicer. Okay, and so we have right here is we're going to be looking for X. We know this is 9,000. We know this is 17.5 degrees. We know that this angle right there is going to equal 1.3 degrees. Okay, and we know that this angle right there is going to be 161.2 degrees. So now we want to figure out what this angle right X is going to be. Well, since we're given, well, an angle side angle, all right, angle side angle, we can use the law of sines. We're going to use the law of sines. Law of sines. The hardest part when you're doing these problems is really the setup and figuring out all the different angles and whatnot. Sometimes that can be the hardest part. Because now we know that the sine of 1.3 to 9,000 is going to equal the ratio of the sine of 17.5 as that is to x. And now we want to solve for x. And so when we cross multiply, we're going to have 9,000 times the sine of 17.5 divided by the sine of 1.3, and that's going to equal our x value. And when you put this in your calculator, that is going to be a very, very large number, which is going to be 119,289.1261, and we know that's going to be in feet. Okay, that's going to be in feet. Okay, if you want to convert that, you can convert that to miles, which is right around 22.6 miles. Okay, and so you can do it either way, but that's what we have for our answer. Okay, so now the question is, all right, what is the next part we want to say? So now it says find the ground distance the plane must travel until touching down. Okay, until touching down. So we found the air distance, all right, the plane must travel until touching down on the near end runway. Okay, so this air distance. Find the ground distance the plane must travel until touching down, all right, on this runway itself. Now, what does that mean? Well, the ground distance that it must travel when our touchdown is actually going to equal this part right here. So if you look at our little diagram up here, you see how I went out right here. We see the plane is actually not by the runway because it's coming through. So we're trying to figure out this distance right there. So if I go out to my one drawing right here, okay, this blue part, we want to figure out this distance, okay, this distance right there. So we'll call that distance G. All right, so we want to figure out distance G. Well, we found out this length X. We have G. This is going to be right here, which is a 90-degree angle right there. Okay. And we can find out this value, all right, this value by essentially, okay, using, well, I guess 1 and 2, the law of sines again, if we want to think about that. Because what we know is that this angle is 18.8 degrees. And now we're going to use this little small right triangle, the small right triangle, to help us figure that value out. Okay, and so going from here, we can use this, all right, So using the small right triangle, we can take and do, if we want to do the law of sines again, for part C, law of sines is using this one, we can say the sine of 90 degrees. Normally we don't do that. Sine of 90 degrees is going to be 1. All right, over, well, we'll keep it in feet. We'll go 119-289.1261 feet. And that's going to equal, all right, we're trying to figure out G, correct? And so what we have right here, 90 in that, so we probably want to figure out that angle right there, okay? And to figure out that angle, we can take 90, all right, plus 18.8, and then subtract that from 180, and we have 71.2. So we'll need that one right there, which is going to be 71.2 degrees. And so we're going to take the sine of 71.2 degrees, and that's going to equal our ground distance that's going to travel. We put this on our calculator. Once again, multiply those through. I'm just going to say this is equal to x. All right. And so we're going to take whatever, just so I don't have to write this out again, we're going to take x times the sine of 71.2. So you need to put that in there, divided by the sine of 90 degrees. Sine of 90 is going to be 1, so that doesn't really matter. And that's going to equal g. And so essentially, g is going to be approximately, okay, if you want to figure this out, it's going to equal 112,924.963 feet, which is, once again, approximately, all right, 21.4 miles if you do that conversion. Okay, so now we found the ground distance, okay, for part C. And now we're going to do one more section, and we want to find the altitude of the plane. So now we want to figure out x, g, and we'll figure out h. And now we're going to figure out h. Once again, knowing all our information, we can use this little right triangle right there, and h, the height, the altitude, okay, the altitude, all right, we're going to call that h. It's pretty easy because, once again, once we find out what g is, we can use sine, not necessarily the law of sines, but the sine, all right, so part D, sine of 18.8 is to h, all right, as that is to g. All right, and in order to solve this, we're going to take what we know for g, and we're going to have h equaling approximately the sine of 18.8 times g, which is, we know, going to equal about 38,443 feet approximately. Okay, and that's what we have there. Okay. Oh, what did I just do? No, that's not what I do. I'm sorry. Oh, golly gee wilkers. Hopefully everybody's stopping right here going, what? Gasp. He's a trig teacher. I was going through there. That didn't seem right when I was doing the calculation on myself. Actually, it's opposite over hypotenuse. And that's x. And our x value is right there. Okay. Oh, golly gee wilkers. So x equals the sine of 18.8. That is what's going to approximately be h. Okay, and that, my friends, if you put in your calculator now, all right, I'm using this value, or the 22.6 miles, depending on what you want to do, all right, is going to give you approximately about 38,443 feet. Yes, I was looking at the answers, and I was also doing the calculations beforehand, so I apologize for that. All right, but that is how we get h, and those are the different values we have. I didn't write it all out for each one, but that's what you can get for all your answers. Okay, so I hope this makes sense. Sorry about that final mistake at the end. We all are human, but this was a very involved problem, had many different things, doing different triangles, using right triangles, setting it up, but using the law of sines no less. So hopefully this helped you out, and will help you solve a lot of other problems in the future. All right, good luck and God bless.